Hello.
Check,
Check
one,
one,
two.
two.
How's it
How's
going?
it going?
All right, so we're
we're
gonna
gonna
do a Kinect top tutorial. No. Have I got rid of the double? Okay, so I think I fixed the audio problem here. So we're gonna go over today all sorts of effects you can do with the Kinect top. So that is the various images that come in from your Kinect. I'll go over all that in a little bit. Going to spend a couple seconds here just showing some fun things you can do without having to go into actual skeletal tracking, which we'll cover in a future session. So here we can see I have each time slice offsetting in space, which is a kind of complicated setup with a bunch of instanced geometry and texture 3D. Maybe we'll get into that. But let's just jump through and check out a few other things. So this is done with a bunch of edge detection on a silhouette, which we'll get to today. Here's another sample of things you can do with edge detection and silhouettes. Another. Not sure why it's running a little slower than usual. Probably because I'm streaming. So even using a 2D source image, you can create all sorts of 3D effects. All right, so enough of that. Let's jump in. All right, so here we have all the modes that we can use the Kinect top in. The default when you add a Kinect is depth, which I've renamed Kinect depth and thusly down renamed all of them. The default for this, you have your normal depth sensor resolution, which you can remap to match your color camera's resolution of 1080p, and you can do a mirror image, which may not be useful for you. Very self-explanatory. The unknown value, sometimes Kinect, just especially around edges, gets noisy, so you can pick a value for it to spit out when it doesn't know. This will be useful later on. Next type of image you can get is the player index, which is a grayscale silhouette that it calculates with its own internal Kinect SDK magic to give you your silhouette. And if I kind of walk out, it'll lose me. And then I kind of pop back in. You can see there's lots of noise, especially when your body is near an object, things get really grainy. But when you're standing up, it gets a little more clear. It's hard because I'm on a headset here. The next image you can access is infrared, which is pretty self-explanatory. So this would probably be a lot brighter if I was having direct sunlight or some lamps that gave off more infrared. I've got mostly LED lighting in this room. This can be useful for various night vision things. We're not going to cover that. May as well delete it. Kinect color in my kitchen right now. Fun. And our point cloud, which encodes in space from the camera's sensor your X, Y, and Z position of each pixel in relation to the camera. Sorry, I'm not explaining that very well. It's a little confusing and mostly useful for an input source into GLSL stuff, which we will not be covering today, but will hopefully get into in a future session. So we can get rid of that. These are going to be our most useful ones for our kind of introduction to using Kinect tops. Sorry, I'm not very articulate tonight. Okay, so a lot of people want to get a silhouette, so that's going to be the first thing we cover. You have one here, but it's gray. If I had more people with me tonight, you would see them each showing up as a slightly different grayscale silhouette, and you could, in theory, key them out separately to each have their own silhouette you could use for masking them independently for whatever purpose. For today, we're just going to deal with keeping everyone the same color if there was anyone else here. I'll do a future video when there's some people around. So the easiest way to turn this into a normal white silhouette on black would be with a threshold less than or equal to. Now we have it nice and punched out. We can use it for anything. One of the most often things I see people asking about who have never really played with it before is how can you key yourself out without a green screen. So I would just camera remap that so it matches my color here. Sometimes it'll lose you, not fun. Okay, and then all you have to do, if you want to do the super cheap way, is just use a multiply. And there you have it. As you can see, the edges are not the cleanest. You can fix this with various blurring and edge detection techniques. If you want to do this a little bit more of an old school way, or not necessarily old school, but I guess just more on traditional idea of keying, you would use the matte top, which basically comps input 1 over input 2 based on the matte channel you select of input 3. By default, it's set to alpha. I'm going to set it to Luma. And then here's a cheap little trick. Just throw a level for your second one. Bring your opacity down. There you go. And then this can be comped on top of any old thing if you wanted. Which is cool. I mean, you could have also just pumped that into here. There's like a million ways to skin a cat, which is nice. Leash. Sweet. So there's your basic isolation from the background. You can also mask out just yourself from the depth image if you want. We'll cover some techniques about that later. So often I see people or have been asked by clients, they've sent me references of stuff where it's a silhouette with lots of trails coming off it. The easiest way to achieve that is just go to your palette browser, image filters, feedback. Whoa. Wow, isn't that fun? And if you look inside there, you can see the basics of how to build a feedback network. which I won't necessarily go over all that. I think that I'll cover that more in depth in a future video. But one thing that's often desirable is to add an HSV adjust with a slight hue offset so that your trails change colors. This will be more apparent if I just use a straight up silhouette. Use a channel mix to take out one of the channels. Oh, wow. Oh, I forgot to mention this comes in as just a red channel. So we're going to need to do a little trick here to turn it into an actual RGBA. Bam. Sorry about that. I always forget these little things when I'm trying to narrate. Last week it was the lag chop. This week it's the constant. All right. So inside our feedback, oh my goodness. Oh my goodness. Now what? Okay, well, I'll show you how to build a feedback loop if you don't already know. There you go. So basically, we're compositing current frame with our last frame, currently in add mode. Could use any other mode. There we go. Okay, so I think the problem I was having was that I forgot to get my alpha to match my Luma. So people love this rainbow stuff, don't they? And you can do all sorts of fun feedback stuff, which we can go into more in depth at a later date. Okay, so now that we know how to make feedback, which is oh so fun, we can use it to control a lot of other things. And I've had people sending me examples wondering how so many different effects are done with dancers or just random people who come up to an interactive installation and you see something that related to their silhouette on screen, but it could be various halftone effects or geometry moving based on where you're standing. And so sometimes that's done using the skeletal tracking that is enabled with the Kinect shop. But a lot of that, people are actually just using the top data from the silhouette and some feedback to smooth out the interaction over time, or to kind of encode a position that slowly disappears. So I'll bring this back to our normal white. Maybe put that blur back in just to smooth it out a bit. Sometimes it's good to add a little bit of black. just to make sure things fade away properly. Okay, so how would you use this to control geometry, you might wonder? Well, that's the beauty of touch. You can convert between like any type of data, sometimes more efficiently than others. So currently this thing is running at 1080p, or, you know. So we're going to want to down res it a couple times to something that'll be a little bit more manageable. That may be a little too much there. Let's start something like that. So, sorry, let me get some water here. See if that shows up in the Kinect. Some things don't show up because the infrared doesn't get back to the sensor. I'll notice sometimes if you're wearing a really dark black clothing, parts of your body will be invisible. So that's something to bear in mind when designing something for the public to interact with. Some people might not show up, and then they get upset because they feel less than human or something. Anyway, back to what we were doing here. We're going to want, I always put a null at the end of stuff, or when I remember to, before changing operator types especially. Let's go with a top to chop. Put it into next frame fast mode. Put our crop to be full image. So now you can see a representation, which is kind of hard to tell. You can kind of see where my arms are, maybe. But we're going to say to just take one channel off it, call it Luma. And then oh my goodness, I just forgot how to do this. Well, okay, thankfully I already have this demo made. Gosh, this is harder to do live than it seems. This is the exact one I was going to show you. Okay. Let me refresh my memory here on the crucial step. All right, shuffle sequence all channels. Right. Okay, sorry about that. So then we will make a grid that is of the same resolution as our source image. So a nice easy way to do that would be info. Let's look at just the res. Pipe that over to our, oh, that's columns. That's one confusing grudge or pet peeve of mine with touch. It's rows and columns, but X and Y is the other way. Anyways, just to make the grid the right aspect ratio, just make it be 1/10 of the resolution or something. Boom. So as you can see, 1980 points, 1980 indices of Luma. Now we can, as well, put a null here in case I want to do some weird stuff. And convert that to channel data with a SOP 2. These bad boys can be merged. Oh, let's use a rename to quickly strip off that 0. Cool, that still looks pretty uninteresting though. So now I'll make a shape that I'm going to instance and make appear only where the silhouette trail is. Let's go with a sphere. Geometry. Maybe that's too small. In the geo, turn on instancing. Let's give this a name that's more sensible. Instance chans, why not? Then you can pick your TX, TY, TZ. There we have a lovely grid. We can add our camera, light, render. Beautiful. While we're at it, let's stop looking at me. Okay, that's still pretty boring though, right? Okay, so in our geo we can map Luma to our scale. Now we have a nice 3D halftone effect. And if we wanted to get a little silly, we could do something. Well, the cheap way to do it is, well, at least cheap in time spent, not necessarily computationally cheap. So you could add a noise, and make it a little more subtle. Maybe not that subtle. Gives it a little bit more liveness, or something. And this can be applied to any parameter, essentially. So it could be something where the effect isn't as much of a one-to-one analog of your body shape to whatever parameter, but it could be, anything. So it could be the pitch of an oscillator synthesizer that's creating weird sounds for your installation, or it could do changing colors, or one thing we could do here would be map our Luma. Instead of size, we could map that to our alpha. Or to maybe just one of the channels. So as you can see, you can map that to anything. So if we picked a shape that you could actually tell what angle it's at, perhaps a box, and then we could take a math off of Luma, rename this R, multiply our Luma by, 180, throw that into our merge. Oh, I don't know if I mentioned this earlier, but it's always good to have a merge before your null that goes into almost anything that you're going to plug a null into that changes data types. In this case, it would be changing it into a geo, but you know, if you're plugging into something else, it's always good to have a merge so you can just add another channel whenever you need it without having to re-export stuff. Sorry, where was I? Oh yes, we can now make our rotation channel look for R. That's actually pretty cool. Oh, that's really cool, actually. I think I'll use that for something. Whoa. What did I just do there? Okay, so say you want to do something like this, but you don't want to have to depend on the Kinect SDK for detecting your silhouette. And maybe you just want to do it for any object that gets within a certain range. So we can do this same setup with our Kinect depth instead of our Kinect player index. So currently our unknown value is set to 0, but 0 represents close to the camera, and then white is your furthest away. So you can see over here into my roommate's bedroom, his furthest wall is almost white because it's at the very edge or near the very edge of the Kinect's range, which is like, I don't know, 15 feet or something. I guess your results may vary depending on air quality. In LA, we got some smog everywhere, so that might be blurring it out. So, since we want to know how close something is, we want our unknown value to be assumed to be as far away as possible. So, over here, just bring your unknown value up to 1. So now all the discrepancies on the edge of me will be considered out of range. Which isn't perfect, but it's better than having glitches in range, triggering where you don't want it to be. So then we can just use a threshold to get stuff that's only within whatever our desired range is. So you can see my hand kind of disappears into the white milk. And you can soften that a tiny bit. Emerging from the fog. And that effect is pretty cool on its own, right? So then we can, maybe not so soft. What's this, the edge of my monitor? Okay. Move the Kinect over a little. Move that SparkFun box out of the way. Groovy. So now I can just hold my hand out about where I want it to work. Swell. Just use a level to invert it so I don't have to deal with changing those values I just honed in. Great. So now we can pipe that in to this null. And I'll put Luma back to our scale as well. So now only my hands that are close enough show up. And again, you can map this luminance to anything. And if you wanted to put that color changing stuff in, like we had before, oops, wrong one, you could in theory use the changing color over time to have other interesting effects. So if I go back to my channel mix here, move the Kinect a little closer again so I don't have to reach out as far. Oh, brilliant. I'll just go back to the silhouette version anyway. So if we go back to our top two, gonna have to do a little bit of modification here. Eh. So we are going to select our comma, select G, select B, go back to calling these RGB. Oh, let's add some asterisks. So sorry I stopped narrating here. I'm just changing channel names back to be something more suitable than they were. Oh. We were already using R, so I'll change that to be called rotate. What the? And we don't have a Luma anymore. You know what? Let's make our rotate be based on R, G, and B. Oh, and we might want to merge these in. I might want to. Oh goodness. Apologies. So the effect might not be exactly apparent, but we're rotating each object about its X, Y, and Z axis depending on R, G, and B values in our feedback trail. But if I just change that back to 1, take off that rotation, we can actually go to instance page 2, and then those RGBs could go in here into our geometry. Then if we go back to page 1, map rotate, let's make it be 360, make the effect a little bit more extreme. That's pretty fun. Heh. So this can also be a fun way to make all sorts of pseudo pixelization, halftone effects, or yeah, as I said earlier, just about anything. Okay, cool. I think I'm going to cut it off here. We've already gone over half an hour. Um, so as I mentioned before, there's a lot more to cover with Kinect, and you can look forward to that in future videos. And I will get to cleaning up these files, post them for my subscribers. Thank you for your support, and see you next time.